Hello everyone! In this video, we are going to talk about the set of real numbers. The set of real numbers is represented using the capital letter R, and it can be classified as either rational or irrational. The symbol for rational is capital letter Q, and for irrational, we make use of the symbol Q prime. Remember, the complement of a set is the set of all elements that are in the universal but is not on a given set. And in this case, the universal is the set of real numbers. And when we write Q prime, this means this will be the set of all real numbers that are not rational. Okay? A rational number is the set of all Q's such that Q is equal to A over B, where A and B are both integers and B is not equal to 0. So this means that if we can express the number as a ratio of two integers, where the denominator is not equal to 0, then we can consider that number as a rational number. For example, we have 1/2 that is rational. 5 is also rational because that can be written as 5 over 1. 0.25 is rational because it can be written as 1 over 4. 0.3333, so this 3 dots here means that 3 is repeated, and it is a repeating decimal. It is rational because it can be simplified or written as 1 over 3. Okay, what about this one? So as you can see here, we are not sure whether a number is really repeated. So, and it is continuous. This means that this number is irrational. And actually, this is the estimated value for pi. Okay. Irrational numbers rather, are of course all the numbers that cannot be expressed in the form A over B, where A and B are both integers and B is not equal to 0. Cannot be expressed. For example, we have square root of 2, square root of 5, pi, negative square root of 11. Usually, the radicals in which the number inside is not a perfect square is an irrational number. Also, decimals that are neither repeating nor terminating is also irrational, such as these examples. Okay. All terminating decimals and non-terminating but repeating are rational. These are examples. And also, non-terminating and non-repeating decimals are irrational. Okay. So this means that all the numbers here, if a decimal is terminating, we can express it as a ratio of two integers. And if the decimal is non-terminating but it is repeating, we can also express that as a ratio of two integers. Okay? Rational numbers can be classified as either non-integer rational numbers and integers, in which the symbol for integer is capital letter C. Non-integer rational numbers, these are fractions, terminating decimals, and non-terminating but repeating decimals. Okay. So those are not included on that group are integers. Integers is any element of the set that consists of these numbers, and it can be divided into three subsets. We have positive integers, negative integers, and 0. However, 0 and positive integers belong to one group, which is the set of whole numbers. That's why we will just classify integers here as either negative integer or whole numbers, and whole number will be divided into 0 and positive integers. Positive integers are also called natural numbers. If we call it as natural number, then we will make use of the symbol capital letter N. Positive integers, usually for integers, since the symbol is um, capital letter Z, we will just write negative symbol here to denote negative integer, and then positive integer on um, as a subscript, a superscript of letter capital letter C to denote positive integer or negative integer for negative symbol. Natural numbers, capital letter N. The positive integers or natural numbers can also be called counting numbers. Okay? Now, how are we going to write the set of real numbers using Venn diagram? And how will the Venn diagram of real numbers look like? So, our universal set will be the set of all real numbers. And since we have two sets under that, we have rational numbers and we also have irrational numbers. These are examples of irrational numbers. And then for rational numbers, we have the set of all integers. So this means that we will just write all the non-integer rational numbers here. We can write it out inside the set of rational number but outside the integers. And then for integers, we will classify it as whole numbers. We can draw the set of whole numbers inside. And then, since integers is whole numbers and negative integers, then we can just write negative integers here, outside. But actually, you can, if you want, you can also draw another circle here to write negative integers inside the set of integer, because negative integers is a subset of integers. And so with the whole numbers. Okay? And then for whole numbers, we have positive integers, which is a subset of whole numbers. And we can write 0 here. Whole number but is not a positive integer. Okay? And then all the positive integers can be written inside. So as you can see here, positive integer is a subset of whole numbers. Whole numbers is a subset of integers. Integers is a subset of rational numbers. And rational numbers is a subset of real numbers. Irrational numbers is also a subset of real numbers. Okay? That's the end of our topic for today. Thank you for watching. Bye!